Hello students, in this video we'll discuss a few questions regarding the amino acid metabolism. So the first question is that we are given a pathway for lignin biosynthesis and we have to choose an option that will maximize the production of lignin. So first we'll take a look at the pathway. There are two initial compounds, phosphoenol pyruvate and erythrose 4-phosphate. They both combine to produce shikimate, which is converted to aerogenate by enzyme X. Then aerogenate is converted to two different options. Enzyme Y converts it into tyrosine and enzyme Z converts it into phenylalanine, which further down the line leads to lignin synthesis. So now, how can we manipulate these three enzymes to maximize lignin production? So our options are: first, overexpress the gene coding for enzyme X. Second option is knock out the gene coding for enzyme Y. Third option is overexpress the gene for enzyme X and Z. And fourth option is overexpress the gene for enzyme X and knock out the gene for Y. Now let's consider all four options. If we only overexpress X, what will happen is there will be more intermediate compound aerogenate, and so the amount of both tyrosine and phenylalanine will be increased. So this will give us some amount of higher production but not the highest. So not the first option. Now what about option 2? We just knock out the gene for enzyme Y. So tyrosine won't be produced and there will be some aerogenate left. But because of the enzyme characteristics, the production of phenylalanine and thus lignin still won't be maximized. Because the aerogenate is still being produced just as the original situation. So also not option 2. Now what about overexpression of both X and Z? Again the same scenario. As long as Y is there, there will be some intermediate compound being directed towards tyrosine production. So the only option for maximizing lignin production is inhibiting the Y and overexpressing X. So then what will happen is there is extra intermediate compound, but there is no other pathway for it to go to. So in this case we'll get maximum amount of lignin. So the correct answer will be option 4. Now this is fine on paper that we can knock out the gene for tyrosine production, but let me know in the comments if you think that this will be a practical solution. Now on to question 2. The second question is about the synthesis of branched chain amino acids leucine, valine and isoleucine. So first I'll give you guys a quick overview of the process. So pyruvate is converted to 2-oxo-isovalerate by the enzyme AHAS. Now from this intermediate compound, another enzyme called IPMS converts it into leucine. Now leucine shows feedback inhibition on two levels. First, for its own synthesis, that is inhibiting the action of IPMS after it reaches a certain concentration, and also of the first enzyme AHAS when it reaches a certain concentration. Now isoleucine is synthesized from threonine, and it also shows feedback inhibition. Now valine can reduce this feedback inhibition from isoleucine. So this is the basic process. Now what the question is that if we knock down this particular enzyme, what will be the effect? So we have four options. First option is both the amount of leucine and valine will go down. Second option is leucine will be decreased but valine will remain unchanged. Now third option is leucine will decrease but valine and isoleucine will increase. And fourth is only leucine will decrease. Now let's consider all the options one by one. Option 1. Will the leucine production go down? Yes, because we are knocking down the enzyme making leucine. So first half is correct. What about the second half? So we are not changing anything there. So at the least it shouldn't be going down. So option 1 is out of question. Now option 2. Leucine will go down. Yes. Now will valine remain unchanged? Now we can argue that because the other pathway is blocked, there will be excess of the intermediate compound. But will this result in excess valine production? The answer is no. Why? Because when it reaches a certain level, it will go and inhibit the enzyme AHAS. So therefore, there won't be any excess valine production. So with this explanation, we can consider both option 2 and 3. There won't be any increase in valine production. So option 3 is out. Valine will remain unchanged. So we have got one correct answer. Now what about option 4? That only leucine will decrease. That is correct, but out of both, this is option 2 has more information. That is correct. So we should go with option 2. Now if you guys find any of the explanations difficult to understand, let me know in the comments. I'll try to explain it in other way. Okay, thank you.